Hey there. Today's going to be a really exciting day. Do you want to know why? It has to do with this drawing behind my head. This is one of my favorite topics in biochemistry. We were introduced to this in our alcohols unit when we learned that primary and secondary and tertiary alcohols undergo oxidation in different ways. And we elaborated on it in our aldehydes and ketones unit, where we learned that aldehydes could be oxidized to carboxylic acids or reduced to primary alcohols, and ketones could be reduced to a secondary alcohol, and our tertiary alcohols don't undergo oxidation or reduction. And today we get to see that application in our carbohydrates unit. So in particular, we'll be focusing on this top thing here. There are reactions that occur within the second, but we won't elaborate on them in today's discussion. But without further ado, we will start talking about some oxidation and reduction in carbohydrates. I have to make my screen smaller. And what's really exciting about this is you see that I am starting this screen with the same screen that's in my background. And that's like double your fun. So carbohydrates have some aldehyde groups, and they also have some alcohol groups. When we're talking about oxidation and reduction, we're mainly talking about the aldehydes and the ketones. So remember that we classify alcohols. I made a mistake. We classify carbohydrates as either aldoses or ketoses. And at that aldehyde and ketone location, we can get some oxidation and or we can get some reduction and or oxidation taking place. So let's look first at the reduction of the aldehyde group on an aldose. So here is the right-handed glucose. I am trying to activate my pen and I don't see it. Oh, there it is. Ooh, the eraser works. Sweet deal. Here is the aldehyde group. And when an aldehyde gets oxidized, it turns into a carboxylic acid. And when an aldehyde gets reduced, it turns into a primary alcohol. So here we're talking about reduction. With this reduction, this carbonyl group right here is turning into an OH group here. So we are essentially turning our aldehyde group into a primary alcohol group. And this is an industrial process that we use, taking ordinary glucose, and there are lots of reasons we do it. When this reaction takes place with the right-handed glucose, it produces sorbitol. And sorbitol has a lot of uses. It, as you can see here, is used as a laxative. It is used as an artificial sweetener. If you look at some of your sugar-free options, some of the sugar-free options have warnings that this contains sugar alcohols. What this does is it takes the ability for this, which provides calories and can undergo metabolism to produce energy, it removes that capability. So when we turn this into a sugar alcohol, we have a calorie-free option, which still has a sweet taste. So Sugar alcohols are often used in candies that are sugar-free, and they can unfortunately have a laxative effect. So here are some options. Some people are not sensitive to sugar alcohols, and you can see that it's used frequently as a non-caloric artificial sweetener in many products. The fact that it's sold as a laxative should have you a little wary if you're eating these items in case it has that effect on you. So when we look at oxidation, if we have this aldehyde group, this glucose, it can be oxidized to a carboxylic acid. And this is one of the ways that vinegars get made, because it produces some carboxylic acids, which are sweet. There are other fermentation processes that take place. But the application that we saw of this earlier this year is we did a lab activity to determine if aldehydes and ketones were oxidized. And we had two tests. One was called the Tollens test. And with the Tollens test, we got the silver mirror coating. And then there were the Benedicts and the Phalings test, which started off with a blue solution and turned kind of a grungy, reddish. And we may have seen these in the lab, or you may have seen pictures, but if the aldehyde is something that can be oxidized, we will get a confirmed positive. Since sugars are aldehydes and glucose is the primary sugar in our blood, when people are pregnant or in a diabetic state, sometimes they can spill sugar over into their urine. And on the next slide, we have an old-fashioned urinalysis glucose test. So you can see this is in the lab. This is an alcohol lamp. This is a Phalings solution, so it's blue. They use the glucose on hand to give positive results. So if the sugar is present in that solution and you put this in it, you will get a brown confirmed positive. And if we put this in the urine and we get a brown confirmed positive, that shows us that glucose is being spilled over into the urine, which in pregnancy could cause alarm, or in any situation where you might be worried about poor regulation of blood sugars and diabetes sorts of situations. So if there is a sugar, it gets oxidized, and since the sugar is getting oxidized, we call it a reducing sugar. And reducing sugars have that free aldehyde group. Now, something weird does happen with ketosis. Ketose, remember, has lots of OHs and hydrogens, just like before, but on that second carbon, there is the carbonyl group. And what can happen is ketones in and of themselves will not form a positive oxidation test, but if you put a ketone in a basic environment or an alkaline environment, it can actually rearrange itself to form an aldehyde. So some ketones will also produce a positive oxidation because they actually just transform and rearrange their molecules. So if a sugar becomes oxidized, it's called a reducing sugar. We are going to discover when we talk about disaccharides, and this is why I introduce this now, we are going to discover that disaccharides, in particular sucrose, which contains the glucose unit and the fructose unit bonded together with a glycosidic linkage, does not have a free aldehyde group. So sucrose is not a reducing sugar. It would not test positive. If we were to take table sugar and put this into a test tube and run an analysis on it, we would not get a positive. But the sugars in our blood and the ones that spill over into our urine will definitely show positive. So these are used as diagnostic tests. Luckily, not so much anymore because they have little sticks that can tell us the information that we need to know. If you can imagine, I cannot imagine that this process has a favorable odor as we're heating up urine in that test tube. So I just shared a couple of examples of oxidation and reduction with carbohydrates. Again, oxidation or the reduction of sugars, simple sugars, results in the production of what are called sugar alcohols. And sugar alcohols, one example is sorbitol. Another example is mannitol. I think that is what you get if you reduce fructose. And sugar alcohols are often used for lots of reasons in industry, as sweeteners, as texture enhancers. The applications are very, very numerous. And then the application of sugars being oxidized is that urinalysis test to see if sugar is being spilled over into the urine, and an old-fashioned test involved using the Phalings or Benedict's reactant to show positive results. And thankfully, we have more refined techniques now. So thanks for watching.